Okay, here's some more examples to figure out what the shape is. And again, is what you want to do is you want to actually figure out the Lewis structures first, and then add to that, use your table to figure out the rest. So nitrogen trichloride is NCl3. So we have nitrogen and 3 chlorines. So we have our central atom is our nitrogen. It's bonded to 3 things, so it's trigonal. It has an extra set of electrons, so it's pyramidal. Okay, so it's trigonal pyramidal. And this is polar because it has more, it's lopsided. It has more electrons on the bottom than on the top. So it's polar. And we're going to go over that in a minute, but that would be polar. Right, now pause it. See if you can get some of these on your own. CH4 is methane. We already did that one. That's a tetrahedron. And this one is not lopsided, so it's nonpolar. The way I know it's a tetrahedron is its central atom is bonded to 4 things. C2H6, put our carbons in the middle, hydrogens around them. And again, we have a tetrahedron. And again, it's nonpolar. Doesn't matter which central atom you choose, they both have 4 around them. C2H4. I'll choose any one of my carbons. It's bonded to 3 things and no extra electrons, so it's trigonal. And it's planar, because there's no extra electrons. It is also nonpolar. It's not lopsided, it's symmetrical all the way around. Acetic acid, you have to know how to write that in order to know how to draw it. And it's H, because acids always start with H. CH3COO. I remember that was a weird way to remember it, but I said the reason we're doing it this way is because when we go to draw it, we'll know exactly how to draw it. So we have our CH3, our C, our O, and another H at the end. Let's see if we have enough. We have 1 plus 4 plus 3 plus 4 plus 6 plus 6. I was running out of room. So we have 5, 8, 12, 12, so we need 24 electrons, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. So we need double bond in here. There we go. Now for this one, we have lots of central atoms. So you can choose this one and call it a tetrahedron. You can choose any of the other ones and call it bent. Now since I have 3 options for bent, I'm going to go with bent. And it is definitely lopsided, so it is polar. Now last one is ammonia. Remember, ammonia is NH3. So we have N, we have hydrogen, hydrogen, hydrogen. So we have trigonal, pyramidal. And it is polar. We have those extra electrons on the top. Okay, now here's where I actually explain what polar and nonpolar is. Basically, it's whether or not they're symmetrical. Are they equal all the way around? So polar is where it's uneven distribution of electrons causing the molecule to have a positive and a negative end. Now this positive and negative end is causing it to be more of a magnet, more of a pull for other electrons. We're going to call it magnet. It's not necessarily made of metal, so don't you think of like an actual magnet, but it can actually pull things with other charges. Like if it has a positive side, a negative side of an adjacent molecule might be attracted to it. Nonpolar means that it has even distribution of electrons, so it doesn't have positive or negative end. So for predicting the following, whether it be polar, nonpolar, ionic, H to H, there's no difference there, so that's nonpolar. H to O, even though there's just 1 there, that's going to be polar, because you're going to have a lot more electrons around that oxygen. NaCl is ionic, because it's a metal and non-metal, so that's definitely going to be polar. And HCl is also going to be polar.